Now we'll talk about slope. And in many ways, slope is the single most important idea to understand about lines in the xy plane. And of course, the test likes to ask about lines in the xy plane, so it's very important to understand slope. Slope is roughly a measure of how steep a line is. So in other words, if a line is almost flat, then it has a low slope, but if it's going up like this, it has a higher slope. Different lines are at different angles, and slope is a way about talking about their slants. So before we get into slope, I'll say throughout coordinate geometry, it's important to think about concepts and problems with three different perspectives. Numeric, what's going on with actual numbers of coordinates. Geometric, what does the picture look like? And algebraic. And of course, many students tend to over-focus on the algebraic and neglect the numeric and geometric. And this produces a limited understanding, and folks don't realize this. They get very comfortable with the algebra, and they say, I want to do algebra, and they don't realize what they're missing. And so if you really want to understand slope deeply, you need to have all three of these perspectives. And in fact, for the very important idea of slope, the geometric and numeric perspectives are the most important, and the algebraic perspective is the least important of the three. And again, this is paradoxical. People get a formula and think, oh, well, if I have a formula, I really understand something. It turns out that algebra is not the perspective that gives you the most insight into what slope is. And it's much more important to think about the geometric and numerical perspectives if you really want to understand this important idea deeply. Okay, let's talk about slope now. One of the most common definitions is rise over run. What does this mean? Suppose we want to find the slope between 2 points. The run is the horizontal separation from left to right. This is always positive from left to right. The rise is the vertical separation between the 2 points as we go from left to right. If the point on the right is higher, then the rise is positive. If lower, then negative. And so run is always horizontal, rise is always vertical. Suppose we want to find the slope between 2 points. A good geometric way to approach this is to construct what I will call a slope triangle. This consists of a slanted segment between 2 points, a vertical leg and a horizontal leg. So point 1 and point 2, those are the 2 points between which we want to find the slope. The hypotenuse there is the line that actually has the slope that we're looking for. And then there are 2 legs, a vertical leg and a horizontal leg. And of course, the vertical leg is automatically the rise, and the horizontal leg is automatically the run. So if we construct this triangle immediately, geometrically, we get the rise and the run. For example, suppose we want to find the slope between 2, 2 and 6, 5. We draw or imagine a little slope triangle. And again, you might be able to just visualize this, but even if you can't, you can sketch this on the scrap paper. It just has to be a rough sketch. And so now we have a slope triangle. And of course, as always, the horizontal leg is the rise. Sorry, the horizontal leg is the run, the vertical leg is the rise. And we see, of course, this is a line that's going to have a positive slope. It has a positive rise. So again, the run is the horizontal leg, the rise is the vertical leg, slope is rise over run. Well, what is the rise? Well, the rise, we go from the line y equals 2. We go from that line at the bottom up to y equals 5. And so the vertical distance along that vertical leg is 3. 5 minus 2, which is 3. The rise is 3. The run, we're going from x equals 2 to x equals 6. And so the distance along that horizontal line, 6 minus 2, is 4. So the rise is 3, the run is 4, and the slope is 3/4, or 3/4. Suppose we want to find the slope between -4, 2 and 5, -1. Again, we draw the slope triangle. Again, the horizontal leg is the run, the vertical leg is the rise. Here, notice that the point on the left is higher. And so this actually has, as we move from left to right, we actually have a drop. In other words, the rise is negative. We go from a height of y equals 2 down to y equals -1. And 2 minus -1 is 3. That's actually a drop of 3. And so that is the rise. The rise is -3. And then, of course, the run, we're going from -4 to +5. That's a distance of 9. So the run is 9. Rise over run, -3 over 9. We simplify the fraction to -1/3. If you are given the numerical coordinates at 2 points, I would suggest using the slope triangle to find the slope. In other words, practice using the geometric perspective. Sometimes you're given an algebraic formula and you have to use the formula for the slope, and so there are times when it is appropriate to use the algebra, but don't make the formula your default. Don't use algebra 100% of the time. This is one of the many examples in which over-reliance on a formula produces a shallow mathematical understanding. And this is something so hard to understand because people get so excited about memorizing formulas. They think if I know a formula, I know something, and they don't realize that over-reliance on that formula actually inhibits them. Having warned you about the perils of over-reliance on the formula, I will give the formula. Suppose we have two general points, x sub 1, y sub 1, x sub 2, y sub 2. And if we're given two sets of coordinates, it actually doesn't matter which one we call point 1 and point 2. It doesn't matter at all. One of the points is point 1, one of the points is point 2. The run is the difference of the x coordinates. The rise is the difference of the y coordinates. Again, the only thing that matters is we subtract in the same order. Here we're subtracting point 2 minus point 1. We have to do that both in the rise and the run. Then we just put rise over run, and that is the slope formula. And so if you're going to use that formula, make sure you understand its deep connection to the idea of rise over run. Don't memorize it as an isolated factoid, but understand how it's connected. So far, we've been talking about the slopes of two individual points. A line has a slope, and in fact, the slope of a line is the slope between any 2 points on the line. If a line has a slope of 1/2, for example, then if we pick any 2 points on the line, the ratio of rise over run will simplify to 1/2. So that's really important. That is part of the magic of a line, that you could pick any 2 points at all on that line, and the slope between those 2 points would always be the same. Let's think about a slope of 2. What exactly does a slope of 2 mean? And here we're going to be thinking more about a numerical perspective. So a slope of 2 could mean that we go right 1 unit and then up 2. So that would be a slope of 2. We could go right k units and up 2k units. So we could have any proportion that we wanted. For example, we could go over 7 and then up 14, something like that. But it also means that we could go the other way. We could go left 1 unit and down 2 units. That's also a slope of 2. Or we could go left k units and down 2k units. So any proportion. We could go left 5 units and down 10 units, that sort of thing. If the point -3, -1 is a point on the line with a slope of 2, then if we go over 1 up 2, then we go to -2, +1. Again, if we start at -3, -1, and if we go left 1 and down 2, then we get to -4, -3. So if you know the slope and you know an individual point on the line, it should be very easy to find other individual points. Again, this is a numerical perspective on the slope. Let's think about a slope of -2/3. Well, that one piece of information contains so much information in it. So it certainly could be a run of 3 and a rise of -2. So in other words, we go right 3 units and down 2 units. So that's certainly true. It also means we could go right 3k units and down 2k units, any proportion of that. It also could mean that we go right 1 unit and down 2/3 of a unit. Sometimes we only want to make a small change and we want to see the fractional change in y. So we could also use that form. It means that we could go the other way with all of these. We could go left 3 units and up 2 units. We could go left 3k units and up 2k units. Or we could go left 1 unit and up 2/3 of a unit. And again, we'd use the fractional form when we were moving very small distances and we wanted to see a very small change in y. Here's a practice problem. Pause the video and then we'll talk about this. Okay, a line goes through 2, -1 and has a slope of 5/3. Find all the points A, B on the line where A and B are integers whose absolute values are less than or equal to 10. So here we're going to start with the point 2, -1. And we're going to start by moving to the right. So we're going to move right 3 and up 5. So 2, -1, if we move right 3, we move from 2 to 5. If we move up 5, we move from -1 to 4. So this gets us to 5, 4. We do that again, we move from 5 to 8, and we move from 4 to 9. So we get to the point 8, 9. And then if we do it again, we're going to wind up with values bigger than 10. So we only get those 2 points in that direction. Now go back to the original point. Now we're going to move left 3 and down 5. So if we start at an x of +2, move left 3, we're going to get to -1. We start at a y of -1, move down 5, we're going to get to -6. So we get to -1, -6. And then if we move left 3 down 5 again, we're going to get to -4, but -11. And again, we have an absolute value bigger than 10, so there's in fact only 3 points that satisfy this condition, and we found the coordinates of all 3. Notice that if a line has a slope of 1, then rise equals run, and the slope triangle is a 45, 45, 90 triangle. You should know that lines with slopes of 1 or -1 make 45-degree angles with the axes. That's something you should know. You don't have to worry about the exact angles formed by any other slanted lines. Simply notice that lines with a slope of greater than 1 or less than -1, that's an angle of more than 45 degrees, so those are steeper than any road that you might walk or drive on. In fact, one very good way to think about slope is think about the roads that you typically walk on or drive on, the hills that you climb up, that sort of thing. See if you can figure out the slopes of those. That's a very good way to develop not only a visual but even a kinesthetic sense of slope. What is true if 2 lines are parallel? What's true about the slope of parallel lines? If the lines are parallel, they must rise and sink, same rise for the same run. In other words, parallel lines have to have equal slope. So that's the very intuitive idea. Everyone kind of gets that parallel lines have equal slope. That's the one that has a lot of appeal to it. Perpendicular lines, this is a little bit harder. What is true if 2 lines are perpendicular? First of all, one goes up, the other goes down, so that means that they have to have opposite signs. If one is positive, the other is negative. Opposite signs is part of the answer, but we need to think about the numerical value of the slope. Think about what happens when we rotate the slope triangle by 90 degrees. So the blue triangle is the original slope triangle, the dark blue triangle. The light blue triangle above is the rotated slope triangle. And now notice that what was the original rise is now the run. And what was the original run is now the rise. So in other words, rise and run swapped places, or numerator and denominator swap places. Well, what do we call that when numerator and denominator swap places? We call that a reciprocal. And so the slopes of perpendicular lines are opposite signed reciprocals. So that's a hard idea to understand. In other words, if the slope of the original line is P over Q, then to get the perpendicular line, we have to flip the fraction over and add a negative sign, negative Q over P. So the original slope is 1/2, then the perpendicular slope, 1/2 flipped over, the reciprocal of 1/2 is 2, and then we have to put a negative sign to it. So positive 1/2 and negative 2, those are 2 perpendicular slopes. So let's practice finding perpendicular slopes. In fact, pause the video here and see if you can find, for all these M1s, what would be the slope of the line perpendicular to it. Pause the video and then we'll talk about this. Okay, for the first one, The reciprocal of 5 is 1/5. So the opposite sign reciprocal would be negative 1/5. So a slope of 5 and a slope of negative 1/5, those are two perpendicular slopes. For the second one, the reciprocal of 3/7 would be 7/3, and so we'd have to make that negative. So it would be negative 7/3. For the third one, it's already negative, so we're going to have to make the negative into a positive. And of course, the reciprocal of 11 over 8 is 8 over 11. So it would be positive 8 over 11. And finally, we have a slope of negative 1/20. Well, the reciprocal of 1/20 is just 20. And because it's negative, the original is negative, we have to make the perpendicular slope positive. So it would be positive 20. And so again, when we're finding perpendicular slopes, we have to take the reciprocal, that is, flip the fraction upside down, and change the sign. Change it to an opposite sign, positive to negative or negative to positive. In summary, slope is rise over run, and that is a very powerful definition. It lends itself well to slope triangles. We find the slope between 2 points with a slope triangle or with the slope formula. And again, thinking about the geometric and numerical perspectives is very, very helpful with slope. The slope of a line is the slope between any 2 points on the line. Lines with a slope of plus or minus 1 make 45-degree angles with the axes. Parallel lines have equal slopes, and perpendicular lines have slopes that are opposite sign reciprocals of each other.